So welcome everyone to week 1 of Space Science with Spice. My goal for this lecture is to teach you how to code with a language called Python and some associated libraries in a physics context. And as always, I've broken the lecture up into 5 sections, the timestamps for each of which and related links are in the description if you want to skip around. And another little tip is that at the start of every section, I'm going to tell you if you have the prerequisite knowledge to skip or speed through the section. You'll see what I mean in a few seconds. And on a more general note, as we begin actually learning stuff, at first trying to absorb all these new concepts may feel like trying to drink from a fire hose, to borrow a phrase from MIT. But be assured that if you really stick with it, after a few weeks you'll be confident in your ability to learn and apply these concepts. And if you don't know me, hi, I'm Zain. You can find my email and Discord in the description. Message me if you need help with anything for this club or school in general, or if you just want to chat, I'm always happy to talk. So now we'll start with part 1, which will be an introduction to computer science. On the prerequisites, if you used a programming language before, consider skipping this, although I'd still recommend you watch to gain a more conceptual understanding of the topic, or at least the terminologies I'll be using. Now, computer science is a huge field that's exploded over the past few decades, but fundamentally, it's really just problem solving. We can think of problem solving as the process of taking some input, which will be the details about a problem, and generating some output, which will be the solution to our problem. And this proverbial black box in the middle is computer science, or the code we'll learn to write. Now, programming itself, or coding, just means giving a set of step-by-step instructions, or algorithms, to a computer to execute and solve a problem. If you've ever cooked using a recipe before, you can think of yourself as the computer and the recipe's author as the programmer. The recipe author provides you with a set of instructions which you read and then follow. The more complex the instructions, the more complex the result. So here's an example of an algorithm, or again, a set of step-by-step instructions for finding a name in an alphabetized phone book. Going in order of the lines, we'd open the book to the middle, decide whether our name will be in the left half or the right half of the phone book, since again it's alphabetized, and then reduce the size of our problem by half by discarding the section where we know our name won't be. We can repeat this until we find our name, dividing the problem in half each time. So with 1,024 pages to start, for example, we would only need 10 steps of dividing in half before we have just one page remaining to check. Now this algorithm is written in something called pseudocode, literally meaning fake code, which is a representation of our algorithm in precise English. And although computers don't actually understand pseudocode, it's really important to conceptually understand the distinct parts of pseudocode before looking at the actual syntax of a programming language, because these rules that I'm about to tell you will likely apply to every single language you'll come across. So if we look at the bolded words, or sorry, the highlighted words from the phone book search algorithm, we'll see that some of these lines start with the verbs or actions like pick up, open to, look at, and we'll call these functions. We also have branches that lead to different paths, all these if, else if, and else statements. These are like forks in the road, which we'll call conditions. Um, and the questions that decide where we go are called Boolean expressions, which eventually result in a value of yes or no, true or false. So is this person on this page? Yes or no. If yes, then call them. Is this person earlier in the book? Yes or no. If yes, or if true, then open to the middle of the book, and so on. And lastly, we have words that create cycles, and this is where we could repeat parts of our program called loops. Just as a general note, in computer science, this process of simplifying a really complex concept like searching a phone book is called abstraction. So part 2 is going to be coding in a language. In our case, this will be Python. And the prerequisite to skip this is if you're already comfortable with Python, you could skip this entire section. Or if you've already taken AP Computer Science A with Java, then I'd recommend watching the first 14 minutes of the video I've linked in the description called Learn Python in 60 Minutes from Java. And I've also linked my own notes on the video, which is kind of like a Java to Python cheat sheet, and I still use that today. So we just looked at pseudocode, which is a representation of our algorithm in precise English, but computers don't understand English. They quote-unquote think in binary, which are strings of ones and zeros. And this is where programming languages come in and allow us humans to translate our instructions into a language that computers can understand. So there are many different programming languages, actually, now that I think of it, including one that's actually entirely made of emojis. I'll link it in the description if anyone is interested. But we'll be using something called Python, which is a really versatile and beginner-friendly general-purpose programming language that can be used in a huge variety of fields. And as a bonus, it's also the most popular programming language according to GitHub's popularity index. I'll link that below too. So you do well by getting a head start and learning it right now. So right now we're just going to look at the actual syntax or the structured language of Python, and the link to this is going to be in the description. Alright, so on that link, we're going to be using this platform called Google Colab, which is really similar to Google Docs, except for it's for coding. You can have a mix of blocks of code and text. Oh, there's a cat up here. It's really distracting. I'm sorry. You can use it by expanding these sections and then running the code or clicking the play button in these code segments to run them. I'd highly recommend making a copy of this collab so you can both, one, tinker with the code, which is one of the effective ways to learn how to code, and two, use this as kind of like a cheat sheet or like a set of notes to add on to and modify as you learn Python. And trust me, this is going to serve you really well if you decide to pick up Python again after a few months if you take a break. I'd also recommend these two resources I've linked right here, or really anything else you find online, because remember, you don't have to memorize or even read these entire two documents. This is the reason I'm pre-recording these lectures too. In the future, whenever you come across something you don't understand in like future lectures, you can pause the video and use this Colab or some other online resource, because the point isn't to memorize code, it's to understand like why we're using this and the structures behind it. So we can jump right into, we're going to start with the basics of Python. So at the very beginning, we start with variables, which basically allow you to store different types of values. So Python, like most programming languages, supports different types of variables called data types, including integers, which are whole numbers, floating point numbers, which are decimals, booleans, which are true or false, we'll get into this later, and strings, which are just text. You don't need to specify the data type of a variable, unlike a language like Java. You can simply assign any value to the variable, and Python figures the rest out. And you assign it using this statement, where you'd say the name of the variable is equal to the value you wanted to assign it to. So for example, if you want to make a variable x equals 3, Python is going to assume it's an integer. But if you assign x is equal to 3.5, then Python already knows it's not an integer, but a floating point number. And on naming your variables, the name can be any combination of letters and underscores, and it is case sensitive. Now, we can do all we want with our variables and our operations, but we need a way to see some output of our code. And the way that we're going to do that is with the print function. And that's just going to be the word print, and in between parentheses, we're going to put either a value or a variable, whatever you want, and that's going to output it's going to output whatever you put there. So we could start with this little sample bit of code. This is going to be for assigning and printing variables. So at the beginning, we're going to have our print statement. We're just going to print this string, hello world. And we'll just run the code and see what happens. Hello world. Yeah, we see that. And then past that, we make a variable called month, and we assign it the string February. We make a variable called date and assign it the integer 24. So we're going to print as a string today is, and then we're going to use this plus operator, which is called concatenation, which basically just means we're going to add strings back to back to back. So today is month, but the output isn't today's month, it's the month of variable, so it's going to see, and the month variable is February, so today is February, then I add a little space here, and then day to string. Basically that just makes it so Python doesn't have to add a number, it knows, okay, it wants us to print like 24 as text. And so we're going to get hello world, today is February 24th. For the sake of versatility, here's another way to print and swap the values of variables. So this program x is 1, y is 2. We have our print function, we have an f, and then we have these curly braces, and then the value for our variable here. And if we run this function, we'll see, so x is equal to 1, and then y is equal to 2. And then we have this other way of assigning variables. So this looks a bit confusing, but really all this is saying is that we have the first value that we want to assign, the second value we want to assign, this first one goes to the first one here, and the second one goes to the second one here. So the value of x becomes the value of y, the value of y becomes the value of x. And these happen at the same time. It's not like x becomes y and then y becomes y, because x is already, you don't have to worry about that. It's going to happen at the same exact time because it's on the same exact line. And as you see, we run the same print statement that we did up here, but this time the values of x and y are switched. So this is something to just keep in the back of your head. You don't need to memorize this. Now we'll move on to operations. So what's really good for us, this being a physics-based club, is that you could do math with Python. We have the basic 4 operations of PEMDAS in order of precedence, with the modulus operator, which basically finds the remainder of a division operator on the same level as multiplication and division. So just parentheses comes first. Exponentiation is these two stars. asterisks, and then we have our multiplication, addition, subtraction. So here's a bit of sample code for mathematical operations. I recommend you pause for a second and understand why each of these outputs that ends up showing up, why these are here. You'll see we have 5 plus 2, especially this one on line 4. If you saw this in a math class, you'd think that x is equal to 2x, so x equals 0. But with coding, it's a bit different. Basically, what you're doing is that you're taking the value of x, which is 7. You're always doing the right side first. So this would be 7 plus 7 equals 14. And then you're kind of dumping that into this variable x. And this variable x takes on a new value, which ends up being 14. We just have a bunch of print statements. We have multiplication, division, exponentiation, and modulus. We see all of these printed here. So again, pause this and look over and make sure you understand all of these. So now we can move on to control structures. So a program sometimes, of course, has to make choices, and these choices can execute different bits of code depending on whether or not a certain condition is true or false. Usually if it's true, then it's going to execute it. So we have these comparison operators, which is equality, greater than or greater than equal to is this, smaller than or smaller than equal to is this, and not equal to is this. Notice how when we're testing two things for equality, so we're going to have something before and something afterwards, and if they're equal, then it's going to return true. Let's say we did is 5 greater than 3, it's going to return true, but if we did 3 greater than 5, then it's going to return false. And that's basically how these comparison operators take two values and it yields a Boolean value, depending on whether or not the expression or the thing that you've written out is true or false. Conditions can also be combined with these phrases, and if there's a long string of them, this is the order of precedence, not and, then or. And the function of these is pretty self-explanatory. Not turns a true into a false, and returns true if both conditions are true. So true and true is true, true and false is false, because of course and means both of them have to be true in order to return true, false otherwise, and or returns true if at least one of the conditions is true. So yeah, we could look at an example right here. Here's the general structure of it. You're basically going to have your if condition, and then your statement here. Always your statement, what you want to have within the if statement is indented. And we could have multiple statements here as long as they're all indented, and the indent lets Python know that these are going to be under the same if condition. Notice that we have one if, there's always one if and one else, and then these elif stands for else ifs, and we can have multiple of those in between the if and the else. So it's basically the computer, as it runs through this, it's going to think, okay, if this condition is true, then we're going to run this, and then we're going to skip over the rest of them. But if this isn't true, then we're going to check the next one. So if this isn't true, well, else if this one is true, then it's going to run this, and it's going to check all of them until it gets to else. And if else isn't, or if all of these are false, then it's just going to run the else statement. Regardless, it doesn't check anything with the else statement. And if there's no else statement, then it's just going to end it and it's not going to execute any of these statements. So we could look at a sample program right here to see how this kind of works. And I really recommend, again, making a copy of this Colab and playing around with these values to see if you could get each of these print statements to show up. So here's an example of how the ands and nots take place. So again, I'll go through kind of how the computer would think about this. You have a is equal to 3 and b is equal to false. So if a is greater than 0, so 3 is greater than 0, that's true. So we can, the computer's thinking, okay, this is true. Then we see and, which means, okay, in order for this to return true and run this, then this has to be true and this has to be true. Therefore, this would run. So we check not b. Well, b is false, so not b would return true. So then we have true, and if you remember, if both of them are true and it's an then and will return true, and then as we can see, if we run this, then it does return this. It is true. Again, I'd recommend you play around with these values and see if a mod 2 is equal to 0, which basically just means if it's even, if 1 divided by 2, the remainder is 0, or b, in this case b would have to be true, and that we can see this reflected in the print statements. And I have a couple of exercises right here in the comments. Again, make a copy of this and try and solve these, show them to me whenever you finish, or if you need help with any of them, I'd be happy to help. Of course, I'll always say this every single lecture, the best way to learn how to code is to actually code it yourself. So make sure, try and put these ideas to the road and try and apply them and try and write your own code. So we're moving on to loops now. While loops will basically repeat code until this condition right here, and this is the general structure, while condition statement. It's going to repeat the statement until the condition becomes false. So it's going to check while condition. If the condition is true, then it's going to execute this, and then it's going to loop back, and then it's going to check if the condition is true, then it's going to do the statement again. So this can go on forever, but it doesn't necessarily have to. So we could see here, here's a sample code. So if we set x equal to 3, while x is less than 10, then it's going to print x, and then it's going to increment 1. So just walking through how the computer go through this, x is equal to 3, so it's going to check while, so this is the condition, x is less than 3, well x is less than 10, it's going to check, well x is 3, so is 3 less than 10? Yes, that's true. So we're going to run through this, we're going to print the number, and then we're going to do the right side first, just the way that variable assignment works is that we're going to do the right side first, 3 plus 1 is 4, and then x becomes 4. So now the x value in the computer's memory is 4. So now we're going to loop back to the while statement. We're going to go while x is less than 10, well x is now 4, 4 is less than 10, that's true, so we're going to execute this, and it's going to go on and on and on. And if we run the code, then we're going to say, yep, it starts at 3, then it prints out 4, 5, and it increments until it gets to 9. And that's because once we get to 9, 9 is less than 10, true, print 9. X is equal to 9 plus 1, so x is equal to 10, and then it comes back here, checks, while 10 is less than 10, well 10 is not less than 10, that's false, and then it breaks out of the code and the program ends. And then here's a quick exercise, predict the effects if we switch the 5th and 6th lines of code, and then test it out. Predict it first, and then switch the code itself, and then test it. And just something to be wary of, be wary of infinite loops. Right here I'm incrementing it, and eventually if we keep adding 3 to 1 it's going to be more than 10, but you never do this. But if it's always true, I'll cancel this quickly, but you're going to get infinite else statements, and I'll stop this before it crashes my computer. Cool, okay. So just be wary of this. This is an infinite loop, and the computer isn't going to point this out. You have to be able to, once you run your code, it's going to run forever, and you're not going to know. Sometimes you want that because you could terminate the program, but better to not have that and have it terminate at some point. So now we have our for loops, and a for loop is like a while loop in that it repeats some section of code until a condition is, or it repeats some section of code until a condition is met. Yeah, but the number of repeats, or I'll call them iterations, is usually known, although we still can run into infinite loops. Sorry. So we have our general structures. This looks like a lot, but that's just because we have 3 different types of structures. Because the range function takes in multiple inputs or arguments. So with our first one, we just have for our variable, this could be any variable I, let's say, and that's just so we could reference it later. We have our counter here. In our while loop, our counter was x, and we reference that in our code. Here, for a for, we'll still have our counter. This could be x, this could be I. I usually use I, and that could be referenced in your statement, in your indented statements. So we're just going to have some variable range. So when you just put one input into the range function, it's going to start with your variable equal to 0, and then it's going to go up to, it's going to go right before the range, the stop value. So 0 inclusive to the stop value exclusive, always incrementing by 1. So it's going to go 0, 1, 2, and then let's say your stop value is 3. It's going to go 0, 1, 2, and then it's going to stop. If we put 2 things in, then we could set a start value and a stop value. So let's say our start value is 3, our stop value is 10. It's going to go 3, 4, 5, 6, 7, 8, 9, and then it's going to stop. And then we have our statement. And then if we put 3, we have our start, stop, and then our step. Before, for these past 2, we've always been incrementing by 1. But for this one, it's going to increment by however many our step value is. We could actually just look at our examples down here. So I'll just run this. The print statement just says, is basically just this copied but moved up. So I in range 6. I is going to start out as 0, and then it's going to increase by 1 until we get to 6, but it's going to stop before we get to 6. There's 0, 1, 2, 3, 4, 5. For this one, we have I in range 2 to 6, so it's going to start at 2, and then stop right before 6. And then I in range 1, 6, 2, just means we're going to start at 1, and then we're going to increment by 2, so 1, and then 3, and then 5, and then once we get to 7, 7 is greater than 6, so we're going to stop right there. And so that's all we're going to be learning in terms of Python right now. We might be learning a bit more later. And I know this is a lot, so if you have any questions, be sure to reach out to me, or even try Googling your question, because there's tons of Python tutorials out there. And most importantly, tinker around with your own code. Definitely try it, and try combining everything you've learned into a single program. I could give you some exercises for that if you want. It's a pretty fun process. Okay, so part 3 is going to be coding. Okay, so part 3 is going to be about coding in an environment, which in our case would be Glowscript. And the prerequisite for this is if you're already familiar with another IDE like VS Code, you can install Python and do everything we're doing here just in VS Code. But honestly, even I'm more comfortable with VS Code myself, and I don't see any benefit to using it over what we're going to be using Glowscript. So use your own IDE if you want. But if you run into some problems, I probably won't be able to help you if you run into anything with installations or virtual environments, simply because I don't fully understand the software myself. So keep that in mind. Just use Glowscript. It's not too difficult. So far we've been writing and running our programs in Google Colab, which is really cool for simple programs and taking notes and sharing them with others. So we should definitely keep this site bookmarked if going into computer science. But when our code begins to grow in complexity and we want to create things like animations, Google Colab simply doesn't have the computational power to handle what we want to do. So we're going to be using this site called Glowscript, which doesn't require you to install anything or store any local files. And you'll see why it's better than another online editor like Replit in part 4, but for now I'll just show you how to log on and how to use it. So in order to use Glowscript, you want to go to the site glowscript.org, which is on the slide right before. And I'm already logged into the site, but but you're gonna have to click sign in at the top right and sign up with the Google account. I'd recommend you just use your personal email, but I haven't gotten any junk mail yet, so that's not really a huge concern. You'll be prompted for a username. Just make it whatever you want. And then in the middle left side of the screen, you're gonna see you're signed in as your name here in bold, and then your programs are here. Click here to go to your programs. And to start, you're going to have a couple of folders. The only real difference between any of these folders is whether it's public or private, which says right here. Public means anyone with a link to your account can look at your programs. Private means only you can look at your programs, and you can click on public or private when you're in a folder to change the settings of the folder. It doesn't really matter which folder you use for the purposes of this club. Just try and keep everything organized, that's all I'd say. So to create a program, we're going to click new program right here, give it a name. I'll just call this Scratchpad because it's just for playing around. And just make sure your name doesn't, or your program name doesn't have any spaces or underscores because it doesn't like that. I'm going to create. Here we have our code editor. So first of all, always make sure you have Glowscript 3.0 Vpython at the top of your document, or else your code will not run. And then at this point we could pretty much code whatever we want. So if we take this program, which was the first thing that we found on our Google Colab, here we have highlighting as well. And if we want to run this program, we'd come up here. We could either click run this program here, we could press Control 1, which is going to do the same thing, or we can press Control 2 to run our program in another window. And this is the one I'll probably be using just because it's easier to close the window and with Control W. So if we run our program, see it pops up here, and we have our output, hello world, today's February 24th. Play around with this definitely a ton, and you'll see it's the same thing. And just the other option, just if you're curious, is this. Oops, I don't know what happened. Oh no, that's not what I meant to do. Yeah. So we're going to come back to this later, but just know that this is going to be our new coding environment and where we're going to be doing the bulk of our coding. So get familiar with this. So for part 4, we're going to learn how to code with a library. In our case, it's going to be, the bulk of our stuff is going to be with Vpython, or Visual Python, which is allowing you to visualize Python. And the prerequisite for this is you could skip if you're already comfortable with making shapes and animating using Vpython. So just to start off with our definitions, library is basically just a reusable chunk of code that you may want to include in your programs or projects. Now you can write libraries on your own, but even more useful is other people can quote unquote package their libraries into files that you can download. Now if we were using an IDE like VS Code, we'd be downloading these packages onto our computer, but the strong point of Glowscript is that it already comes with the library we want, Vpython, so we can jump right in to using the functions from the Vpython library. So before we start, if you want to learn how to use Vpython, or really any library you find online, because there are a ton of them, I really recommend you look through them. any library you come across, if you look online, you'll probably find amateur tutorials, but there will always be documentation from the original creators of the library that explains each of the functions and how to use them. This right here is Vpython's documentation, which is linked below, which is actually more interactive than most with these drop-down things on the side. So keep this saved somewhere, and make sure you're using the Glowscript documentation for Vpython, not the normal Vpython documentation, because they're slightly different. So just before we jump into Vpython itself, I just wanted to show basically Vpython, of course with Visual Python, you might have saw in the introduction, is we're going to be making 3D shapes, and the area where we create them is going to be called a canvas. That's what I'll be calling it, which is basically a graph with an x, y, and z axis pictured here. The positive x goes to the right, positive y goes up, and positive z goes towards you. And of course the center, or the origin, is the point 0, 0, 0. So when we work with our visuals, keep this kind of coordinate system in mind. So finally, we're going to start coding a bit with Vpython, and the most simple thing that you can make is just making a plain sphere with this function sphere with parentheses afterwards, no arguments, no inputs. If we run this program, we are going to see Vpython. So this is the canvas of Vpython. Basically how I'm controlling this, first of all, is I use scroll to zoom in and out. You hold right click and drag anywhere to rotate your item, and as you can see we're rotating our sphere around, the dark and the light side. And then if you press shift, left click, and then you move your mouse around, you can pretty much drag the canvas around, and then you can play around with this, move around, and look at your sphere from all different perspectives. So definitely try this right now. Yeah. So if we go back to editing our program, if we want to specify the position of a sphere, because we should build up more complexity, we're going to give an argument or an input to the sphere function. We're going to tell it the position, or pos, is equal to a vector, which basically just means we're giving a direction, a distance, or the pos is equal to the vector. Oops, vector. And here we're just going to input a set of points. We could just say 1, 1, 1, 1, which is x1, y1, z1. And if we run, we'll see that our camera always starts looking straight onto 0, 0, 0, the origin, but our sphere is slightly offset from that. One in the x direction, one in the y direction, one in the z direction. If we turn, we can see how it's kind of offset in the z direction. We can also feed the sphere function more arguments. So we put a comma, and then we specify stuff like, let's say we want to say the radius is equal to 4. We could set the color equal to color dot, let's say, green. And then if we run, we'll see that we now have a fairly big sphere moved offset. It has a radius of 4, so it looks like it's more centered, and the color is green. So yeah, this is how you'd specify the type of object and feed it some parameters or some arguments to customize it. And just a side point real quick, this type of formatting is up to you. Here's how you could put it on one line. Usually what I prefer to do is after the parentheses, I like putting an enter and it'll automatically tab. And after each comma, you can put each new argument on a new line. The last one here. I just think this looks neater, this is what I'm going to do, but functionally if we run this program, we'll see it ends up being the same exact thing. So if we go back to edit, of course, what we can do is that we can take all these arguments here, and we can also set them equal to variables. So I'll show you what I mean. If we make a variable, call it anything, let's say offset, and set it equal to that vector 1, 1, 1. We set our radius, or we'll just call it r, equal to 4. Then we set our color, Shrek, equal to color.green. And then we change all these arguments. So the position is going to be the offset, and remember we're just dumping this value into we're dumping the vector into the offset variable, then we're feeding it here. It's pretty much going to give us the same thing. We have our radius is equal to r, we have our color is equal to Shrek. If we run it, we'll see we get the same exact thing right here, our sphere. Yeah, so far we've managed to create a sphere, but once the program runs, there's no real way for us to access or change the sphere again. So to do that, we're going to start by assigning the sphere a variable. We could choose anything. We'll call it, let's say, Tony. I don't know. We could call the sphere Tony. So there's just a variable, and if we run it, we'll see that nothing different happens. We get the same exact output. except for the only difference is that internally within the computer, the sphere now has a name or a reference attached to it, a variable. And I know that seems weird. It might seem weird to be storing a sphere in a variable the same way we store numbers or text in a variable, but that's the beauty of a programming language like Python. It'll treat like 3D objects like this the same way it treats a number, a vector, a text. It's all just data stored in this one location, in this case our Tony variable. So you could think of these variables as kind of buckets where we're putting values, if that makes sense. Now, if I want to change something about my sphere, like its position, I can access it by saying the variable name, then dot, then the attribute, which in this case is going to be our pos or our position, dot, and in this case we want to change the x attribute. So we have Tony, we have position. Then within that, the offset is just referencing this. Within this, we want to change, let's say, the x position. We can say pos.x, and then we can set that equal to, let's say, 1 in this case. Or sorry, it was already at 1. We could set it to 3, and if we run our program, we're going to see it's moved slightly to the side. That's not too noticeable. Let's try setting it to something like 10. Then we'll see Tony is way out there on the side. I don't know why I call it Tony. So you might have noticed that it was originally at 1, 1, and then we changed it, but we didn't exactly see it. We didn't exactly see it move. We only see it at the final position, and that's because the computer moves through these lines very, very quickly. And so if we want to have a noticeable or appreciable change, I need to be able to animate this thing. I want to be able to control how fast this code executes. And to do that, we're going to need a loop. So I'm going to get rid of this. And what we're going to be doing is that we want a counter variable. Let's just call it I. We'll set it equal to 0. Our first value is usually 0 for our counters. And then we're going to make a while loop that goes over I, let's say 10 times. So it's going to start with I, and it's going to go through this. And if you remember, whenever we have a while loop and a counter, we always need to increment our counter. So we're going to say I is equal to I plus 1. And so this is going to run 10 times. So 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So within our actual loop, we could set our change to the sphere here. So we could say, let's say Tony dot pos dot x is equal to, and this time since we want to do it repeatedly, we're going to take its current position. So Tony dot pos dot x. Then we're going to, let's say, add 1 to it. So it's going to move to the right 10 times, and we'll change the radius back to 1, just so it's a little clearer. So we'll see if we run this. Oops. See? We get the same thing that we had before, where it moves straight to the right. And that's because, again, the computer is running through this loop incredibly quickly. So what we want to add here is a function called the rate function. And this is going to allow you to specify the number of loops or the number of frames per second. So we're going to start with just rate is equal to 1, or 1 loop per second. And if we run, we're going to see it goes 1, 2, 3, 1 a second. We can speed up the rate to make it go quicker, so it's going to do all of it in 1 second, and it's going to go really fast. Yep. And just to make it run for longer, we'll set I. We could set I to a very big value, so the loop goes over a lot of times. But in this case, let's just set I equal to 0. We'll set equal to 10, but we'll increment I by a smaller value. Let's say 0.1 or 0.01. It's still going to go, whether we set this very big or this very small, it's going to go over the loop the same number of times. It just, we usually, later you'll see when we're dealing with units of time, we want our little steps in time to go very, very quickly to reflect real life. So if we run this program now, it's going to move at the same rate for a lot longer. And you'll see it's kind of jittery. So what we can do is that we could set the change to be a bit smaller. And if we run again, we'll see that it's moving a little smoother. If we set the rate to be very high, we'll set it to 1,000, and then we run, we'll see how it goes. Oop, that's a bit too fast. So to make it a bit slower, let's say we'll set the change in position to be very, very small. If we run it again, we'll see how, wow, finally we have, oops, it didn't run enough times. We'll set this equal to a very big number. We'll see that now it's actually moving kind of smoothly. This looks like it's actually being animated. The animation thing was kind of a lie, because really we're just making, we're changing the position of the sphere over and over again. But yeah, we finally have smooth animation. So this kind of gives you a rule about animating things with Python. This is something you should remember. In order to have smooth animation, we want to have very small, or a lot of steps, a very fast rate, and small changes in our value every single time. And this is something you'll see when we start animating things like planets. So now I'm just going to leave you with some exercises with the Vpython that you should do on your own. I highly encourage doing these yourself, or at least trying them, because again, I'll say this over and over and over again, because I wish I heard this before. The best way to learn how to code is by actually coding. You can't just watch me and think it's all going into your head, truly. Of course, if you need any help or want a hint or want me to look over your code, just reach out to me. I'll be happy to help. I have a lot of free time. Actually, not really. So the first exercise is going to be replacing the sphere with a box. Your little hint here is that you want to go through your documentation of the Vpython linked below and navigate that site and kind of understand, okay, how would I replace my sphere function with the box function? Or it's not called the box function, I don't think. And then we can, your next exercise is trying to make the sphere or the box, whatever you want, go around smoothly in a circle. And of course, it's a physics club, so it's really going to help to think back to your math classes, understand, well, how do we define a circle, what different functions do we have in a circle, and try and find other functions in Python that might help you out. And your third exercise is going to try and make a sphere that's accelerating in one direction, let's say the x-axis, meaning it's constantly moving faster and faster. Like you're pressing on the gas pedal of a car, it's going faster and faster and faster. Its velocity is increasing. So for part 5, this is just going to be about your feedback, your one opportunity to insult a teacher. So here's our weekly feedback form, of course linked in the description again. It shouldn't take more than 3 to 5 minutes to fill out. And of course, don't be afraid or feel bad about criticizing me. This club isn't about like studying for a test or following a curriculum. It's just about having fun and exploring computational physics. So your feedback could actually change how I do things. There aren't that many of you yet, so really take advantage of that. Of course, I want this to be fun for you guys. And if you're not in the Discord, make sure to join and invite your friends by sending them a link. I'll be posting stuff there. We're talking about stuff there. And on kind of an ending note, I know all of this may feel like a lot to some of you, especially if you're a beginner, but definitely go back and rewatch the parts you don't understand. That's why these lectures are pre-recorded. And reach out to me if you have any questions via Discord or email. Again, those are linked in the description. If you're on Discord, just type at Zain Kamal in the channel and ask for help, and I'll come onto a voice chat or just chat with you as soon as I'm available. And I'll be happy to walk you through problems or just talk through stuff or give you more resources. So thanks for watching. That's it. And again, okay, see you next week. Bye.